Welcome to this second to last week of the machine learning specialization. I'm really happy that together we're almost all the way to the finish line. What we'll do this week is discuss recommender systems. This is one of the topics that has received quite a bit of attention in academia, but the commercial impact and the actual number of practical use cases of recommender systems seems to me to be even vastly greater than the amount of attention it has received in academia. Every time you go to an online shopping website like Amazon or a movie streaming site like Netflix, or go to one of the apps or sites that do food delivery, many of these sites will recommend things to you that they think you may want to buy, or movies they think you may want to watch, or restaurants that they think you may want to try out. And for many companies, a large fraction of sales is driven by their recommender systems. So today, for many companies, the economics or the value driven by recommender systems is very large. And so what we're doing this week is take a look at how they work. So with that, let's dive in and take a look at what is a recommender system. I'm going to use as a running example the application of predicting movie ratings. So say you run a large movie streaming website and your users have rated movies using 1 to 5 stars. And so in a typical recommender system, you have a set of users here. We have 4 users, Alice, Bob, Carol, and Dave, which I've numbered users 1 through 4, as well as a set of movies, Love and Last, Romance Forever, Cute Puppies of Love, and then Non-Stop Car Chases and Swords vs. Karate. And what the users have done is rated these movies 1 to 5 stars. Or in fact, to make some of these examples a little bit easier, I'm actually going to let them rate the movies from 0 to 5 stars. So say Alice has rated Love at Last 5 stars, Romance Forever 5 stars. Maybe she has not yet watched Cute Puppies of Love, so you don't have a rating for that. And I'm going to denote that via a question mark. And she thinks Non-Stop Car Chases and Swords vs. Karate deserve 0 stars. Bob rates at 5 stars, has not watched that, so you don't have a rating. Rates at 4 stars, 0, 0. Carol, on the other hand, thinks that deserves 0 stars, has not watched that, 0 stars, and she loves Non-Stop Car Chases and Swords vs. Karate. And Dave rates the movies as follows. In a typical recommender system, you will have some number of users, as well as some number of items. In this case, the items are movies that you want to recommend to the users. And even though I'm using movies in this example, the same logic or the same framework works for recommending anything from products a website might sell, to restaurants, to even which media articles or social media articles to show to a user that may be more interesting to them. The notation I'm going to use is I'm going to use NU to denote the number of users. So in this example, NU is equal to 4 because we have 4 users, and NM to denote the number of movies, or really the number of items. So in this example, NM is equal to 5 because we have 5 movies. I'm going to set Rij to be equal to 1 if user J has rated movie I. So for example, user 1, that is Alice, has rated movie 1 but has not rated movie 3. And so R11 will be equal to 1 because she has rated movie 1, but R31 will be equal to 0 because she has not rated movie number 3. Then finally, I'm going to use Yij to denote the rating given by user J to movie I. So for example, this rating here would be that movie 3 was rated by user 2 to be equal to 4. Notice that not every user rates every movie, and it's important for the system to know which users have rated which movies. That's why we're going to define Rij to be equal to 1 if user J has rated movie I, and it'll be equal to 0 if user J has not rated movie I. So with this framework for recommender systems, one possible way to approach the problem is to look at the movies that users have not rated and to try to predict how users would rate those movies. Because then we can try to recommend to users things that they are more likely to rate as 5 stars. And in the next video, we'll start to develop an algorithm for doing exactly that. but making one very special assumption, which is we're going to assume temporarily that we have access to features or extra information about the movies, such as which movies are romance movies, which movies are action movies. And using that, we'll start to develop an algorithm. But later this week, we'll actually come back and ask, what if we don't have these features? How can you still get the algorithm to work then? But let's go on to the next video to start building up this algorithm.